These are my prediction for paper 3 AQA A Level Chemistry Exam 2025. So we've learned so far from paper 1 and paper 2 that the examiner this year for AQA are trying to be more unpredictable. However, paper 3 has a certain structure. So let's start off with the structure of paper 3. So you're going to have several questions about practical skills, usually 2 to 3 different practicals. You will have some knowledge questions related to these practical, and they most probably will ask you to draw a graph from results, some math questions, and there will be 30 multiple choice questions at the end of the exam. So what are the practical first? So you have 12 required practical in your specification. Any of these could come in the exam. The pH curve is very unlikely because you already had the pH curve in paper 1, and also there was a practical question in paper 3 last year about pH curve. Aspirin or senses of solid products are also very unlikely, or definitely not going to be in the exam because there was already a question about aspirin in paper 2. And then the reaction rate, even though reaction rate was in the paper 3 last year, but because they are quite unpredictable this year, they might decide to do the same thing this year and bring a question about the reaction rate. So even though I think it's less likely based on just prediction, but it's never excluded. So please include this in your revision as well. So which ones, in my view, are the most likely ones? So enthalpy change using calorimetry is a very common one, and it hasn't been in the exam over the last 2 years, so it might be in the exam this year. Mostly will be the calculating enthalpy change for solution or the solution rather than the enthalpy change for the combustion. Then measuring the EMF of electrochemical cell, probably setting up an electrochemical cells to measure the standard electrode potential with some questions related to that. TLC and chromatography, I think this might be in the exam this year, and I'm going to talk to you about what I expect to be related to this particular practical. Making a standard solution and titration, so this is also one of the practical that I think that they are very likely, and you need just to make sure that you know how to make a standard solution. If they give you the concentration of that standard solution and a certain volume, what apparatus are you going to use, what glassware are the most appropriate, and also the final volume. You need to calculate how much you're going to use, applying the information they are telling you in the question. They might as well do some titration on the standard solution form, and they may include some pH calculations at the end as well. Organic practical using distillation. This is one of the practical that I think very highly likely to be in the exam this year. So it's very common for all of these questions to ask you about the hazards, safety, and mistakes in the setup. So let's start with the first practical. So as you can see here, I say reversible reaction, Kc and Kp. Even though there is no direct practical that you have that link that is related to that particular topic. However, these topics didn't come at all in paper 1 and paper 2. And these are one of the most common topics. Basically, on all of my prediction, I said there will be a question about Kp in paper 1 and there will be a question about Kc in paper 2. But if they didn't show up at all, that means that because they're going to be in paper 3, at least this is what I think, or that's what I predict for you. So how does this link to your practical? So you have two experiments that you've done as part of your required practicals that are reversible reactions. So these are the dehydration of cyclohexanol and esterification. So both of these are reversible reactions. So it could be a starting point that they start with this practical, and then they're going to have follow-up questions about reversible reactions and the different factors affecting the yield, or maybe calculate the Kc as well. So there might be a potential 6-mark questions as well about a specific reversible reaction and different factors affecting yield. What are the optimal conditions for a particular reaction? And they could also follow that up questions about the use of catalysts. So we know that some reactions, like the Haber process, which is the formation of ammonia from hydrogen and nitrogen, they use iron as a catalyst. And this is an example of the use of heterogeneous catalyst or heterogeneous catalysis. So there could be also follow-up questions about that and about catalyst, because I think catalyst will be one of the things that, or one of the topics that will be in paper 3. Distillation practical as well. So these are the things that they normally ask about. So if there are flammable substance present in your reactant or in your solution, then you should use water bath or electric heater. Don't forget the use of the anti-pumping granules because they prevent large bubbles from forming and liquid doesn't boil too vigorously. The bulb of the thermometer should be at the junction connecting to the condenser where it's connected to the condenser to measure the correct boiling point. Water must enter at the lower point and leave at the highest point when we talk about the condenser. So when you cool the condenser, water will be in from the bottom and will be out from the top. This is because the water in this case will fill the condenser. We need to make sure that water fills the condenser and also for more efficient cooling. The system should not be airtight. This is because gases might expand and there will be more pressure building up inside that could cause explosion. Purifying organic molecule is part of the question that could come with the reversible, with these distillation questions or for any organic practical. So you add water to remove water-soluble impurities in the washing step. You should add a drying agent to remove any excess water, like anhydrous magnesium sulfate. Use a separating funnel to remove water-soluble impurity from the product where you have two layers. Volatile liquids can be purified by distillation. So if the boiling point is in close range, you should use fractional distillation rather than the simple distillation. Recrystallization has already been in paper 2, so it's not going to be in paper 3. The second practical is the chromatography and TLC. So TLC is a potential topic in the exam this year. In the multiple choice question, they mainly tend to ask about chromatography techniques like gas chromatography or column chromatography. However, I want to tell you about the main thing that you need to know about the different types of chromatography and about the TLC. So for high performance liquid chromatography or liquid chromatography, we have a stationary phase and we have a mobile phase, or even for column chromatography, we have a stationary phase and a mobile phase. The stationary phase can either be a solid or it could be a liquid that is fixed on a solid. And then the mobile phase is always a liquid. The separation will depend here, the separation between the different component and the mixture will depend on the polarity difference. So the different components have different polarity, so they can be separated based on that. So it's mainly used when you have substances with high boiling point because, or in a liquid mixture that has the component have high boiling points, because if they have lower boiling points, we will use gas chromatography as a preferred method for separating these components. Polar stationary phase, if you have a polar stationary phase and you have less polar mobile phase, then the less polar compounds will be eluted first and vice versa. So basically the component will move with the mobile phase, and then the more polar the mobile phase, the more polar ones will move faster with it. If you have less polar mobile phase, then the less polar components will move faster. That also depends on the distribution between the stationary phase and the mobile phase. So if the stationary phase is less polar, it will retain the less polar components, while you have a mobile phase which is polar, so it's gonna take the polar components or the polar ones faster, will move faster than the less polar one, and vice versa. For gas chromatography, this is, as I said, would be used for compounds with lower boiling points. The mobile phase here is going to be a gas in case of gas chromatography. If the stationary phase is polar, then the less polar components will be eluted first. The role of the gas here is just to push the different component from their attachment on the column. It doesn't play any role in dissolving the different components because it's just an inert gas. So the main factor here affecting the separation of the component would be the polarity of the stationary phase. So if you have a more polar stationary phase, then the more polar components will be retained more on that stationary phase, and then the less polar ones will move faster, and vice versa as well. So if the stationary phase is less polar or non-polar, then the polar components will be eluted first. For TLC, usually we do the TLC on a different component in a mixture that do not have any color. So you cannot actually see it as colors when you finish the TLC. So you have to use a developing agent on the TLC that will help you to visualize the spots for the separated component. these are not colored, as we said. So you can either use UV lamp, because we normally for TLC we use a fluorescent background on the TLC, and this can shine under a UV lamp, and then the spots will hide this fluorescent dye on the TLC plate, so they appear as dark spots. Or if you are separating mixture of amino acid, you can use non-hydrine, which gives a purple spot for each of these, or you could use iodine, which gives a brown or purple spots. Mass spectrometry can be used in conjunction with GC. And this is a potential question because mass spectrometry hasn't come in paper one, and it's one of the most topics in paper one, and it wasn't in paper one this year. So maybe they're going to ask you a question where they have this setting of GC with mass spectrometry, and they're going to ask you questions about mass spectrometry. Practical 3 is the calorimetry and enthalpy change. So calorimetry as a practical hasn't been in the exam over the past 2 years, so it might be in the exam this year. I personally think it might be more at the calculating enthalpy of solution rather than enthalpy of combustion. Practical 4 is the electrochemical cells and measuring of the standard electrode potential, one of the topics that are possible in paper 3 this year. So one of the things that I want to tell you about or draw your attention to related to this topic are the effect of the concentration and pressure on the EMF value. So if the concentration of the ions at the cathode where reduction take place, or where we have the oxidizing agent, the value of the EMF will increase. And if the concentration of ions at the anode, where we have the reducing agent or where oxidation takes place, that if they increase, then that will decrease the value of the EMF. Increasing the pressure for gas electrode will decrease the standard electrode potential. And you need to be aware of the standard conditions when we measure the standard electrode potential, which are the 298 Kelvin as temperature, 100 kilopascal as pressure, and 1 mole per decimeter cube for the concentration of all solutions. Practical 5 is the functional group chemical test. So you need to know all your tests for the functional group. For alkenes, we have the bromine water test where they decolorize bromine. The carboxylic acid, we have the sodium carbonate test where they give you effervescence, where this is because of carbon dioxide produced. Carbon dioxide will turn lime water cloudy. For alcohols, you have you test them by using the acidified potassium dichromate solution. So only primary and secondary alcohol will give you a positive test where it's change of color from orange to green. The tertiary one give you negative test. A reaction with metal and test for hydrogen, also for alcohol. So if you add some metal, the alcohol will react and then hydrogen will be produced and you can test for hydrogen. Halogen alkanes, you can use sodium hydroxide and then add silver nitrate test to compare the reactivity of different halogen alkanes, because different halogen alkanes, when you add sodium hydroxide, there will be substitution reaction, and then the bromine or the halide will be released, will react with silver nitrate, and will give you the precipitate. For aldehydes and ketones, we have tolerance test for aldehydes only, which gives you the silver mirror, acidified potassium dichromate only for aldehydes, positive for aldehydes, negative for ketones, and the filling reagent test, which is also for aldehydes, where it changes color from blue into brick red precipitate. Now I'm going to move on to talk about the topics that are potential for the multiple choice question. The first one is the polymers. Polymers has been an extensive question in paper 2, so it's less likely in paper 3. However, DNA wasn't in paper 2. And the things that might be a potential question for paper 3 and MCQ related to DNA are: how does cisplatin bind to DNA? So you need to know that cisplatin, which is a complex, the two chlorine is replacing or is substituted by the two nitrogens on the guanine nitrogenous spaces. So this nitrogen here on 5-member ring is the one that links to the platinum in the complex. Also, the formation of the base pairs. So remember that the adenine makes 2 hydrogen bonds with thymine, and guanine makes 3 hydrogen bonds with the cytosine. Maxwell-Boltzmann distribution curve is one of the most common topics in the multiple choice questions. Just remember that the curve will be more skewed to the right by increasing the temperatures. because more particles will have higher energy, more than the activation energy. This is why increasing temperature will increase the rate of the reaction. The use of the catalyst will push the activation energy value to the left, so lower activation energy, but the curve remains the same. For higher concentration, we will increase the value, or will increase the area under the curve, and the highest point will be higher. It will be higher all over, and so more particles will have activation and will have energy higher than the activation energy. So increasing concentration will increase the rate of the reaction. Isomerism. So usually there will be questions about isomers in the exam, either as a part as a follow-up question if there is a question on hydration, electrophilic addition, nucleophilic substitution, or nucleophilic addition for carbonyl group. So you would expect a follow-up question on isomerism, or they could come in the multiple choice question. So make sure that you go over the basics at least. Make sure that you know how to draw the optically active isomers, so the two isomers which are optically active, how to differentiate between the Z and E isomers, which starting material could give you E and Z isomers in case of the dehydration, or if we do the elimination reactions. Organic reactions, so just have a quick refresher on all of the organic reactions, their names, conditions, and products. You don't need to go over the mechanisms because sometimes they ask about mechanism, but it's not very common in paper 3. Chemical tests for ions, so test tube reactions. These are the sample test tube reactions that can be done to identify the following ions. So group 2 ions. We use sodium hydroxide to identify magnesium. We use sulfuric acid to identify barium. Ammonium ion, we usually warm with sodium hydroxide and test the fumes with litmus paper. The halide ions, we use acidified silver nitrate, or we use an acid and then add silver nitrate to give us the precipitate. And then we test for the solubility of the precipitate using ammonia. For the hydroxide ion, we could use magnesium. For the carbonate, we use dilute hydrochloric acid, where carbon dioxide is formed, and it can be tested with lime water. For the sulfate ion, we use barium chloride, but we have to add an acid before that, like hydrochloric acid, and then we add barium chloride. It will give us a white precipitate. And then for the aqua ion, it already came up in paper 1, but still there is a potential question about the aqua ions and their reactions, precipitation reaction, especially within the multiple choice questions. So one of the points I want to draw your attention to is the fact why we add the dilute acid before the test for halides with silver nitrate, and before we test for the sulfate with the barium chloride. This is because we want to remove any carbonate in the solution, because they will interfere with your test. So if you have carbonate and then you added silver nitrate, that will give you a precipitate. So you want to exclude that the precipitate is due to the carbonate. So basically remove any interference. So you have to add the acid first. And the same for the test for sulfate, because if you add barium chloride straight away and you have any carbonate, that will give you a white precipitate as well. So you have to exclude the carbonate by adding the acid. If there is any carbonate, it will be removed because carbon dioxide will be formed. Then the pH, so it comes a lot in the exam in paper 3, mainly in the multiple choice questions. You need just to go over the main equations, so make sure that you know the different equations, because you're going to use it in one or two of the questions. Buffer solutions was already in paper 1, so it's less likely in paper 3. And pH curves as well was in paper 1 this year. And also there was a long question about pH curves in last year exam paper 3. So it's quite less likely in paper 3 this year. Shapes of molecules, there will be a question or two about shapes of the molecules in the multiple choice questions. So remember how to deduce the shape, or how to find the shape of the molecule in relation to the number of electron pairs. The effect of the shape on polarity is also one of the potential questions in the multiple choice. It's one of the common questions. So if the molecule as a whole is polar or not based on its shape. For example, carbon dioxide has polar bonds, but the overall molecule is non-polar. This is because the dipoles work in opposite direction, so they cancel each other out. Carbon tetrachloride or tetrachlorocarbon is another non-polar molecule because it's a symmetric molecule. So these are the shapes that you need to go over and try to remember for your exam, the name of the shape, the bond angle, because they tend to ask you which of the following has this particular shape or which of the following has the wrong shape or has the correct shape. So you should be able to remember how to find the shape and what are the different shapes called and what are the bond angles. 33 elements. This wasn't in paper one this year, so it's there is a potential question in paper three, especially in the multiple choice questions. Catalysis, it's quite common unless it came in paper one. I think this year there was nothing about catalysis, so there is very good possibility that it might be in paper three this year. So make sure that you revise everything about catalysis, the difference between homogeneous and heterogeneous catalyst, the poisoning of the heterogeneous catalyst, all of that. Please make sure that you go over this topic. Transition metals, so they tend to ask about the shapes of the transition metal complexes and reaction of aqueous ions and complex, usually in the multiple choice questions. The calorimetry is very unlikely this year because there was a long question about calorimetry in the paper three last year, and they asked also about the calibration curve and about the calculation of the delta E. Or for all of these three, I think it's quite unlikely unless they ask for to calculate the delta E or the frequency or the wavelengths within a multiple choice question. Bonding, so remember hydrogen bonding, they tend to ask about polymers, which ones show hydrogen bonding or which molecules show more hydrogen bonding than other. Remember that carboxylic acids can have more hydrogen bonds than alcohols, and then the ethers or the other molecules that don't have any NH or OH will not show any hydrogen bonding. The difference in the melting point of different compounds as well, they tend to ask these questions, and the delocalized electrons, so which of these species has or doesn't have delocalized electrons. So remember that graphite, metals, and benzene ring are the species that have the delocalized electrons. This is very common in the multiple choice. These topics are very common in paper one, but they did not feature this year. So these are time of flight, mass spectrometry, and Born-Haber cycle. So there will be, for me, I expect that there are potential multiple choice questions related to these topics. For mass spectrometry, make sure that you know the two types of ionization and which ion will reach the detector first. Of course, the lighter one or the lightest one. For hypercycle, just make sure that you go over the calculation and the definitions. So what are the most common questions in the multiple choice questions section? So I collected the main question as they come in the multiple choice. So the first one is about the shape. So which shape is not correct? So some complexes or compound with their shapes and ask you which one is not correct. Which central atom has a lone pair of electrons? You should be able to identify that or calculate it. What compound has a permanent dipole? So this is about the symmetry and the cancellation of the dipole. Why nitric acid is used prior to testing the halides with silver nitrate or HCl prior to testing the sulfate with barium chloride, as I said before, to get rid of the carbonate that may interfere with your experiment. Which of the following has the highest ionization energy? So they tend to ask about ionization energy in the multiple choice question. What has the localized electrons? As we said, graphite, metals, and benzene. Which of the following is not correct about halides or halogen? This is very common in the multiple choice. Make sure that you know the trends for the halides, you know their electronic configuration, you know about their properties, because they tend to ask a lot about that in the exam. Which of the following has reduced pH by half? So they can get you a certain volume of a certain acid or a base, which has a certain pH, and they're going to ask you which of the following would reduce the pH by half. So you have to calculate the pH in order to find which one will reduce or increase the pH, basically affect the pH. Which is the correct oxidation state of the following, or which one has the atom in its highest oxidation state? You should be able to calculate the oxidation states because it comes in the multiple choice questions. Which species can or cannot act as pronested Lowry acid? So remember, pronested Lowry acid are these species which donate hydrogen ion in solution. So something like H3O plus ammonium ion, H2O itself, H2O can act as a pronested acid or a base, and carboxylic acids, hydrogen carbonate, and hydrogen fluoride, all of these can act as pronested acids. What is the correct charge on certain amino acid at certain pH? Very common in the exam. Remember, at higher pH, the carboxylate anion will be existing as carboxylate. It will lose the proton, and the ammonia will remain as it is as NH2. However, at lower pH, when it's acidic condition, the carboxylic acid will remain as COOH, while the ammonia will be. They usually tend to ask you a question about the product from a certain reaction, and they tend to just name the reactants and products or give you the structure formula for these ones. For example, what are the product from the hydrolysis of this particular compound? Or what is the product when one phenyl ethanol is oxidized, for example? My advice to you is to try to draw the structure of the compound before you attempt to answer the question. Also, which of the following can be attacked by a nucleophile? Remember, a nucleophile can attack alkyl halides or the carbonyl group in aldehydes, ketones, or for acid derivatives. Which of the following has an unsymmetric carbon? So asymmetric carbon is the chiral carbon or the carbon that has four different groups attached to it. Which of the following is an isomer to compound X?